This question is from GATE 2012 Mechanical Engineering paper, question number 21. A circular solid disc of uniform thickness 20 millimeters, radius 200 millimeter and mass 20 kg is used as a flywheel. If it rotates at 600 rpm, the kinetic energy of the flywheel in joules is dash. So the given things are: uniform thickness of the solid disc is 20 millimeter. We'll write T is 20 millimeter. Radius of the disc 200 millimeter. Mass is 20 kg. It is used as a flywheel. So from this information we can see that the motion of the disc is rotational, and so we can find out the kinetic energy as the rotational kinetic energy of the flywheel. It is rotating at 600 rpm. So capital N is 600 revolutions per minute. Let's see how kinetic energy will be found out. As flywheel is in pure rotation, we can write kinetic energy of flywheel is equal to half into mass moment of inertia I into its angular velocity square. Now our job is to find out the mass moment of inertia and the angular velocity. Mass moment of inertia I will be given as mr square by 2, which is the mass moment of inertia of disk. You need to remember this. It's a standard result. We have mass is 20 kg, radius is 200 millimeters. As we need to find out kinetic energy in joule, that is Newton meter, will substitute all the values in meter. So radius in 200 millimeters, in meters it is 0.2 meter. Square divided by 2. Mass moment of inertia comes out to be 0.4 kg meter square. Now we need to find the angular velocity omega. We know the RPM 600, so we can find omega using 2 pi n by 60. N by 60 is F, that is the revolutions per second, and 2 pi F gives us omega. This will be equal to 2 pi into 600 by 60, which is nothing but 20 pi. 20 pi when calculated comes out to be 62.83. Let's substitute and find out the kinetic energy. We have kinetic energy is equal to half into 0.4 into 62.83 square. This when calculated in the digital calculator gives us the kinetic energy of flywheel, which is 789.57, almost equal to 790. The unit is joules. Let's go back and mark the correct option. So we have the answer. Kinetic energy of flywheel in joules is 790. Option B. To learn about flywheel analyses in detail, you can refer to the NPTEL video Module 6, Lecture 2, Flywheel Analyses from the course lecture series on Dynamics of Machines. This course is by Professor Amitabh Ghosh. He is from Department of Mechanical Engineering of IIT Kanpur. I hope this solution will help you clear it out. Thank you.